Okay, let's do binomial expansion. So, binomial expansion. And so you're going to be asked to expand x plus y to the nth power. And so it might be easy if it's to the first power, the second power, maybe even the third power, but I'm going to be asking you to expand to like the seventh power. So we need a faster way. So let's start expanding this. So x plus y to the 0 power is 1. Let's expand x plus y to the first. Well, it's simply x plus y. Let's expand x plus y squared. And we know through the FOIL method, it's x squared plus 2xy plus y squared. Let's expand this to x plus y to the third. On the side, and I'm going to write this and erase it, I like the square method. So basically, if I'm doing x plus y to the third, I'm going to multiply x squared plus 2xy plus y squared. And then over here, like an Excel spreadsheet, I'm going to multiply that by another xy. I have x cubed plus 2xy squared plus x squared y. I'm sorry, this is 2x squared y. Xy squared, 2xy squared, y cubed. So once again, it's like all the columns and rows. It's like a lot of FOIL. And so if I combine these, I end up with x cubed plus 3x squared y plus 3xy squared plus 1y cubed, or just y cubed. We'll need a 1 in there. Now, I'm not going to do the math. You can do these on your own. So you can do another big square, multiply by x plus y. Let's see what happens. It turns out that x y to the fourth is x to the fourth plus 4x cubed y plus 6x squared y squared plus 4x y cubed plus y to the fourth. And I can do another one, and I can do x plus y to the fifth, because I'm making a point, obviously. And it turns out that, some of you might say, I see what's going on here, but if you did it the long way, you know it's x to the fifth plus 5x to the fourth y plus 10x to the third y squared plus 10x squared y to the third plus 5x y to the fourth plus y to the fifth. A couple of things we notice here. We notice that so whatever n is, so we have, if it's to the 0 power, we have 1 term. If it's to the first power, we have 2 terms. If it's 3 to the second power, we have 3 terms. So the n, that means n plus 1 terms. Okay, another thing we notice is that we look at the x and the y. And so we notice that we see that in the first term, it starts at the highest power and then descends. At the same time, the second term, the y, starts at the lowest power, 0, and ascends. And we can see that here. If I throw in little ones, let's throw in little ones here. 1, 1, 1, 1, 1, 1, 1, 1, 1, and you know what? Let's throw in y to the 0. So here's y to the 0. Here's x to the 0. Here's y to the 0. Here's x to the 0. Here's y to the 0. Here's x to the 0. Here's y to the 0. Here's x to the 0. And we're good to go. So, we have y to the 0 and x to the 0. So what we notice, once again, the observation is that in each term, from the first one, the x starts at the highest power and descends in power. The y starts at the lowest and ascends to the highest power. We see that every single time. X to the third, y to 0. 3, 2, 1, 0, 0, 1, 2, 3. 4, 3, 2, 1, 0, 0, 1, 2, 3, 4. 5, 4, 3, 2, 1, 0, 0, 1, 2, 3, 4, 5. Now the next thing that's going on is these numbers in front. And these numbers in front, the coefficients, actually have an interesting characteristic. They're actually Pascal's triangle. If we take the coefficients off, 1, 1, 1, and then I can put secret ones there. There's a secret one here, secret one there, 1, 1, 1, 1, 1, 1, 1, 1, and I take all these coefficients, and I make it's 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1. Now some of you might say, hey, Mr. Rather, I noticed that 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and the 1s go along the column. You would not be wrong. That is not a coincidence. That actually works out. In the last show also, 1, 5, 10, 10, 5, 1. And so you might say, Mr. Adler, you know what? If this is the row 0, 1, 2, 3, 4, 5, and you can quickly create the 6th row or the 7th row. 1, 6, 15, 20, 15, 6, 1. Now, so this, once again, this is known as Pascal's triangle. Pascal's triangle, and it has a lot of amazing, characteristics. A lot of them, for example, you're not responsible for this. For example, if I add up the row across, it's the power of the row. So the 0 row, 2 to the 0 is 1. It's kind of cool, right? What's 1 plus 1? 2. Well, what's 2 to the first power? 2. 1 plus 2 plus 1 is 4. 2 squared is 4. This is 8. And so on and so forth. You're not responsible for the course. But what are you responsible for? What do you need to know? Well, it turns out that these actually correspond to those combinations that we spoke about in the beginning of the year. If you recall, a combination is choosing, choosing R items from N items without order. And if you recall, for example, you have four sweaters, and you have to choose 2. How many ways can you choose 2 sweaters from 4? And you'd say, okay, Mr. Adler, well, if I label my sweaters A, B, C, and D, I can choose AB, I can choose AC, I can choose AD, I can choose BC, BD, and CD. I won't say C, as I said before, order doesn't matter. You can go back and look at the old videos. Is there a formula for this? Yeah, well, the notation was NCR or NR. So it was 4, choose 2, and 4, choose 2, and the formula for this, if you recall, it was N factorial over R factorial times N minus R factorial. And then we went through the whole thing, and so you did 4 factorial over 2 factorial divided by 4 minus 2 factorial, and it turned out to be 6. But it turns out that there's a much faster way of doing these these whole combinations. It turns out that all of these, this is kind of cool. All of these actually are. These are combinations. So this is row 0, 0. It turns out this is 0, 0 equals 1. If I have one thing, how many ways can I choose nothing? 1. If I have one object and I want to choose 1, there's only one way to do that either. It turns out each row of Pascal's triangle is actually a combination. Let's look at row 2. I have 2 objects. I don't want to choose any of them. I can only do that one way. 2 choose 0 equals 1. I have 2 objects, and I need to choose one of them. Well, I can choose the first one or the second one. What's going on over here? I have two choose 2. You say, okay, let's choose 2. How do I figure that? Well, I know it's 1. You can quickly figure that out using Pascal's triangle. So if I say 3 choose 0, you go, okay, well, row 3 choose 0, 3 choose 1, 3 choose 2, 3 choose 3. 3 choose 0, 3 choose 1, 3 choose 2, 3 choose 3. It's awesome. And now you know 4, 2, 5, 6. So the idea is, we can summarize binomial theorem by saying that x plus y to the n is equal to, it's n choose 0, x to the n, y to the 0, plus n choose 1, x to the n minus 1, y to the 1, plus n choose n minus 1, x to the 1, y to the n minus 1, plus n choose n, x to the 0, y to the n. So once again, we see here, so we see that, so this is the formula in the book. Okay, let's try some other prompts. So the textbook is going to ask you to expand this out. They're just going to say, so for example, one other thing I didn't mention, all these exponents, the sum is always to the nth power. So 2 plus 0 is 2, 1 plus 1 is 2, 0 plus 2 is 2. So we'll get back to that. Okay. Let's do some problems. Let's get some problems now. So they might say expand the first 3 terms. So, x plus 2 to the 5th power. So you say, okay, you know what? So the first term is 5 choose 0, x to the 5th, y to the 0, plus 5 choose 1, x to the 4th, y to the 1st, plus 5 choose 2, x to the 3rd, y squared. And so on and so forth. A couple of observations. As we said before, if it's to the 5th power, we know we're going to, for the 6th row in Pascal's triangle, 5 choose 0, 1, 2, 3, 4. We know because if it's to the 5th power, we know there's 6 terms. Another thing you might observe is that the x power starts at 5 and descends to 0, and the y power starts at 0 and ascends to 1. Another little thing that I kind of brought up was that, once again, what's 5 plus 0? This is 5. What's 4 plus 1? 5. What's 3 plus 2? 5. Nice. Now let's get to so IB's not going to ask you that. They're going to ask you this question. They're going to say, what is the x to the 3rd term? X to the 3rd term of 2x plus 1 to the 5th. Because it's just easy to not determine it. They want to figure this out. So you say, okay, so we need a new method. Well, it's not really a new method. I'm waiting for time. Good. So I call it the Adler method. So first of all, they're asking for the x to the 3rd term. Well, hold on a second. What does any term look like? Well, you say, okay, well, this is to the 5th power. So the coefficient is 5 choose something, right? Times 2x to the something, times 1 to the something. Well, they're telling me I want x to the 3rd term, so you know what? This better be 3. Okay? Well, another observation we made is that the exponents that have to equal 5, if this is 3, that means this is 2. And then here's the last part. This is fun. It turns out that this 0, that's not a coincidence. That's not a coincidence. So this 3 goes over there. 5 choose 2. And what you have to do is first pull out all the constant stuff and then leave the extra. So we have 5 choose 2, 2 to the third, 1 squared, x cubed. This is what I'm interested in. Figure out what 5 choose 2 is. Now, personally, you can do it the long way, or add their cheat method, throw down Pascal's triangle. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. 5 choose 0, 5 choose 1, 5 choose 2, 5 choose 2. There's my 10. 10 times 8 times 1, 80x to the third. Let's try another one. Once again, if the second you see this, throw Pascal's triangle down, it'll help you. Let's try another one. And I'm going to leave Pascal's triangle up there. How about we said, what is the x squared term of, x minus 4 to the 6? Okay, no big, same idea. I don't want all the terms. I don't want to expand the whole thing out. I don't need to expand the whole thing out. So let's see, I know that the x squared term, I know that every single term is 6 choose something. I have x to the something, and pay attention here, please. It's negative 4 to the something. As x starts at 6 and goes down to 0, negative 4 starting at 0 and going up to 6. So you have to pay attention to the negative. Okay, well, I need x squared. So this is going to be a 2. This is going to be a 4. And therefore, this comes down here. This is a 4 here. Nice. So let's pull all the constant stuff out. 6 choose 4, negative 4 to the fourth, and I have my x squared. I'm interested in this part. Obviously, for numbers this big, it's going to be a calculator. You can use your calculator, figure out how to do NCR on the calculator, or, once again, 5, 1, 6 choose 1, 6 choose 2, 6 choose 3, 6 choose 4, 6 choose 5, 6 choose 1, 6 choose 0, 6 choose, sorry about that. 6 choose 0, 6 choose 1, 6 choose 2, 6 choose 3, 6 choose 4 is 15 times 16 times 16. Let's see, what is 16 times 16? Hey Siri, what is 16 times 16? Hey Siri, 256 times 15. Hey Siri, 256 times 15.
256 times 15 is 3,840.
Nice. Should we try another one? Something they might ask for the constant term. That's just the last term. So let's put in, you know what? This shows up and it's shown up in the last 2 exams. So let's put a more advanced one. How about 2x plus 1 over x to the 8th? And they want to know what is the constant term. So you know what, let's make it to the 4th. I'll give you a little break. How are we doing for time? Good. It looks weird. You're like, we haven't done this before. This is a weird problem. How do we deal with this? Well, it's not difficult at all. Same approach. The constant term is the number without an x. So first of all, let's get this set up. We have 4, choose something. I know the 2x is raised to the something, and I know the 1 over x is raised to the something. So you say, I don't know. Well, I don't know what number to put. I don't know what the constant term. I can't. There's 2 x's here, and we're going to have to combine them. No big deal, right? No big deal. First of all, what is it raised to? I don't know. I don't know in math. It's an x. But you know what? Let's make that big. Here's big. I know that regardless of what I do, the sum of the exponent is going to be 4. So you know what? If this is b, this is going to be 4 minus b. I'm just slowly moving ahead. Let's pull all and so this is 4 minus b, this is 4 minus b. So it's either going to be 4, the numbers aren't going to be that large. Keep calm. Let's pull all of the constant stuff out. So we have 4 choose 4 minus b. We have 2 to the b. And what we're left is x to the b and 1 over x to the 4 minus b. Okay. This has nothing to do with what we're looking at. As we said, we're looking for the constant. So you know what? Let me fool around with this a little bit. X to the b, well, remember this. I'm going to write this. Think about what I did. Remember, if I brought this up, this became -1, and I multiplied through. So we have x to the 2b minus 4. Well, I want the constant term, which means I want this equal to 0. When b equals 2, that's when I got my constant term. Plug b in here. For v2, you get 4 choose 4 minus 2, 2 squared. What's 4 choose 2? Let's see. 4 choose 0, 4 choose 1, 4 choose 2. 6 times 4, 24. The constant term of however I expand this out will be 24. Okay, there's going to be a part 2 with a more advanced, because more advanced questions have shown up in the later years.